So I'm this guy standing on a planet. Our planet's pretty big compared to me. Really, I'm just a speck standing on this big planet. But the planet, compared with the star, is just another speck. And the Earth is orbiting the sun, and the sun is a huge star. And our star may be a big deal to us, but my friends, our star is just another speck. So I'm a guy, I'm a speck, living on a speck out on the edge of the galaxy. I mean, it's not really in downtown Milky Way, it's way out on the side. We're just a speck on a speck, orbiting a speck. But I'll tell you what else. There's billions and billions of stars, billions and billions of specks, and then billions of galaxies. I mean, I'm a speck, living on a speck, orbiting a speck in the middle of specklessness. But then I think, I'm this little brain. I have this brain. It's only this big to think about all of this, to think about the vast emptiness of space. I can reason that I'm a speck on a speck in the middle of specklessness, and that's cool. That's worthy of respect. And you can't help but wonder, with those billions and billions of specks, are there other specks out there? That would change everything, because then you know that these little brains are not alone. And that, my friends, is worth thinking about.
The Eyes of Nye. The Eyes of Nye.
Since we could first form the question, we must have wondered, are we alone? Is there life out there among the stars? You see, astronomy is a humbling undertaking. Our ancestors probably thought, no, the world is flat. And they accepted that all the members of their immediate tribe comprised the whole of the human family, that the Earth was the center of everything. But now we may be able to presume that even our existence is not unique, that there are living things everywhere among the stars. And we call this study astrobiology. You see, we may be on the verge of the most important insight of all, as we search for and possibly discover other life on other worlds. What are we actually looking for? We're actually looking for a radio signal from somewhere in outer space.
Right. Presumably, if there are intelligent beings out there, they're flooding the galaxy with radio waves. They're falling right here. Some of them will fall onto the metal mirrors out there, and we'll pick them up.
Now, what is the strength of that signal? Is it as strong as an FM radio station?
You know, a feather dropping on the ground here would have, billions, trillions of times more energy than the signals falling on those things. But we can find them. We can find them.
What makes you think they're out there?
Well, it comes down to this. There's a lot of cosmic real estate. There are 400 or 500 billion stars in our galaxy. There are 100 billion other galaxies, each with a few hundred billion stars. You add that all up, that's a lot of real estate. So just on the basis of the numbers, you figure that, unless this is some sort of miracle here, there's going to be other life out there, and some of that life is going to be intelligent. So that's kind of the bottom line.
Is the Earth just this unusual, if I may, rare Earth, or is it pretty common?
Well, we don't know the answer to that. And there are some people who would argue that, the Earth is kind of special. But I don't think so. We don't know of other planets like the Earth, but I think the reason we don't know is we don't have the telescopes to find them yet.
Now, you might wonder, why don't we just build a rocket to take us to the stars? Well, we can't, because they're too far away. If there were a highway and you were driving to get to an average nearby star, say 30 light years away, it would take you 330 million years. Well, if you had a rocket, oh yeah, you could cut it way down to 1.2 million years. No, we can't get there that way. We can't do it. They're too far away. Instead, we have to come up with other schemes. So for that, my friends, read on. If we discovered a signal from another world, what do you think would happen?
We're not going to hear extraterrestrial Neanderthals with this sort of thing. We've got to hope that there are at least a fair number, thousands in our galaxy, say, of civilizations that are, if you will, at least at our level, and maybe beyond our level, and that they've been broadcasting to space for a long period of time.
So we get this signal. Are we going to be able to understand it?
Yeah, I doubt that we'll be able to understand it. You give the output of your computer modem to cavemen, they're not going to figure it out either. So maybe we won't understand it, but at least we'll know they're on the air. We'll know they're there. But this is the first time in all of human history that we could build something like this and actually have a good shot at finding it. That's what makes this exciting.
And is a chance worth taking?
Of course it's worth taking. No, of course it is. I mean, can you think of anything more interesting than finding out that we're not the only game in town?
This rocket is headed to Mars, and on top of it is a rover that's just loaded with instruments that will help us look at Martian rocks very carefully from way back here on Earth. We'll examine those rocks for signs of water and maybe even evidence of Martian life. Or maybe they'll lead us to another place to look at other rocks, to look for other signs of water and life.
People, I have got some exciting news. Life has been discovered on Titan.
What? Of course there's life on Taiwan. It's one of our best markets.
Not Taiwan, Titan. It's one of the moons of Saturn. This is a whole new market. It's virgin territory. We can have the first product penetration on a brand new planet or moon or whatever. But the important thing is we can grab 100% of the market.
What are the demographics?
Well, it's a little sketchy right now, but it looks like they're segmented worm-like creatures that swim in seas of methane miles below the ice that covers the surface.
How long does it take to get there?
About 7 or 8 years. But the marketing is going to get there way ahead of time. And that's why I want to have a series of 30-second spots ready for the next Super Bowl. I want some ads that position Fizzy Cola as the brand of choice for the worm people on Titan. Let's target the younger worms. I would like to see preliminary sketches by the end of the week. We are going to Titan.
But we consider the limits of life continue to expand. Until just a few years ago, we thought that all living things had to be on or near the Earth's surface, where there's plenty of water and sunlight. But recently, we've discovered all kinds of living things. Living in environments we once thought were too harsh, too hot, too cold, even too radioactive for life. And we call these organisms extremophiles because, by our standards, they love extreme environments. We find microbes living in acid, living in boiling water, under thick layers of ice, at the very bottom of the ocean where it's dark and cold at extreme pressures. Astronauts retrieve spacecraft parts, which have been sitting on the moon in the vacuum of space for years. And when they got the parts back to the Earth, there were microbes on them that had made the trip, and they were still alive. So maybe there are billions of planets out there with living things we've never even imagined. And from their point of view, we're the weirdos. We're the extremophiles. Did you ever think of that? Here we are breathing this highly chemically active, corrosive, toxic oxygen atmosphere, and we're stumbling around on only the very driest parts of this otherwise lovely, sea-soaked little metal planet. See, it could be a wild world or world of worlds out there. By studying life in extreme environments here on Earth, we may be able to get an idea of what life would be like out there. There might even be life in our own solar system, perhaps even on our closest neighbor, the red planet, our ruddy buddy, Mars.
We're standing on Little Red Hill.
Little Red Hill.
It's my favorite place on Earth because it's a lot like Mars, actually. It's red and it's mostly lifeless, but in fact, this little square we're standing on is teeming with life. Underneath these rocks, say this one for example, you see that layer of green? These are algae that are living under the rocks. They live under the rocks because the rock traps moisture, so it's a little wetter under the rock than it is in the soil nearby.
Just that much wetter.
Yeah, so this is a rock I broke earlier. You open it up, it's white inside. The light comes through the red layer, goes through the right rock, and reaches the algae. So they're living under little rock greenhouses.
So how much light gets through there? I mean, 5%? 1%?
About 1%. In fact, if you hold it up to the sun, you can sort of see the sun coming through it. If you look at it through the magnifying glass, you can see it. It looks kind of like grapes, little clusters, little balls. And in fact, adding a little water makes it really clear that it's a set of cells rather than a mineral deposit.
It looks like moss.
Yeah, tiny, tiny moths.
Yeah. Now, how did these organisms come to be here on the Earth?
Well, these are some of the oldest organisms on Earth. They're the most ancient. We find them early in Earth's history, these type of cyanobacteria, they're called. In fact, these bacteria are the ones that are responsible for the oxygen in our atmosphere. These are the only other species besides humans that are capable of changing a planet. They changed it by making oxygen 2 billion years ago. And these are the organisms I'd really like to find on Mars. Because if there were organisms like this on Mars's history, well, maybe Mars could have had the kind of changes that Earth has had. There's really good evidence that Mars at one time, maybe long ago, had a lot of water on the surface. We see gullies that don't have any water in them now, but have all the signatures of water having flowed through them. So we see dry rivers, dry lakes, and maybe even dry ocean floors. And since water is what life needs, that's why Mars is interesting.
This is sodium bicarbonate. You find it in the rocks around here. It's what chemists call a base. This is cream of tartar. It's made from grapes. It's an acid. Now, when acids and bases mix, they often react. But you can see there's no reaction. There's no way for the electrons to get from one atom to another, no way for the atoms to interact. But watch what happens when we add water. Now, they're reacting like crazy. So for life, just add water.
Tommy, what is the most important thing for life as we know it to exist?
Wood?
Mary?
Is it liquid water, Mr. Sanders?
Very good. So, where should we look for other life forms in the universe?
We should look in...
Wait, let's see if Tommy has an answer that will get me big laughs in the teacher's lounge.
We should look for planets that could possibly contain water.
Gee, Mr. Sanders, Tommy got it right.
That was excellent.
Don't hit me, Mr. Sanders.
I was not going to hit you, Tommy. I was just patting you on the head. Like...
Ah!
Well, I guess Tommy is not feeling well, so let's return to more of the Eyes of Nye.
What if we found life on Mars?
Well, it'd be interesting. It would tell us, well, here's another planet with life. But the real question would be, is it the same life? See, these guys and us, we're the same. The genes in these algae are very much the same as the genes in your cells and in my cells.
They have DNA.
They have DNA. And it's got the same alphabet that we have in our DNA. And it's the same words in their genes as in our genes. What if we went to Mars and we found some organisms and they had a completely different alphabet, completely different words in their genes, completely different chemistry? Well, that would be interesting, because then we'd have two really different types of life. When we go to Mars, we're not just searching for life, we're searching for alien life. We're searching for something that's different.
NASA C.
NASA C is ready.
NASA MEM.
NASA MEM ready.
SMA.
SMA is ready.
This rocket is the product of huge investments in both money and manpower. And you might say, what are you going to find out there, millions of nautical miles away? Well, we don't know. That's right, we don't know. We know what we're looking for, but we don't know what we're going to find. Mars is an unknown horizon, a new frontier. This ship is going places we've never seen. This is the human imagination at its best, exploring, seeking, working on that question. Are we alone?
4, 3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
Of course, anybody who's been to the movies can tell you
You got company.
there's life in outer space.
What terrors of the deep await the exploring spacemen? Underwater creatures swarm from the depths to exact their primitive vengeance upon the invaders from Earth.
If aliens are anything like you and me, they live on planets. See, they can't live on stars because the energy coming off the surface of a star is so intense it incinerates molecules. So we figure aliens live on planets going around distant stars. Now, distant stars are, well, distant. So any planets that are orbiting them are too far away, too small, and too dim to see. but there are people working on it.
I'm Dr. Deborah Fisher. And my job is to find planets around nearby stars.
And you have found some planets.
That's right. Collectively, astronomers in the world have found about 100 planets now orbiting other suns, other stars. And our group has found about 70 of these.
70 planets. Now, what are these planets like?
Well, they're different from our Earth, much different, because the technique that we use is actually more sensitive to finding large gas giant planets like our Jupiter, which is 317 times the mass of our Earth. So it's these large planets that we're finding.
What made you start looking for these things?
We're trying to find out if our planetary system is common, if it exists, if there are platforms for life around these other stars. Because before 1995, for all we knew, these stars were just desolate, bright objects up in the sky.
It wasn't until 1995 that a group of Swiss astronomers detected the first planet orbiting a star much like our own sun. This was the first direct evidence that planetary systems like our own are not unique. There may be planets orbiting stars all over the universe. How do you go about finding a planet on another star?
Well, unfortunately, what we'd like to do is go up and take a picture of the star and see the planet sitting right next to it, and then in one night we'd have the front page of the New York Times covered. But instead, we actually exploit the laws of physics a bit.
We measure the speed of all kinds of things thanks to a discovery by Christian Doppler. Listen to this. As the ringing moves towards you, it sounds higher pitched. As the ringing moves away, it sounds lower pitched. This is the Doppler effect. As the clock moves towards you, the waves of sound are pushed closer and closer together, and you perceive a higher pitch. As the clock moves away, the sound waves are pushed farther and farther apart, and you perceive a lower pitch. This is true for clocks, and it's true for cars. It's also true for light. And this is how Deborah Fisher and her team infer the motion of stars. See, their light varies in color, in frequency, ever so slightly. So she figures that's a result of the star having motion toward us and away from us. Notice that if you and I are moving together, there's no change in the pitch of the sound. It's only when there's relative motion, toward you or away from you, that you perceive the Doppler effect. Well, let's get back to the show, because time flies!
So on night one, I'll come up and I'll measure a star like this, take an observation. It will take about 10 minutes and take about an hour to analyze. And I'll get the position of all of these lines. And then I'll come back a week later or a month later, and I'll observe the star again. And if there's a planet there that's caused the position or the speed of the star to shift, then you'll see these lines in a slightly different place.
This is the motion that planet hunters look for. This is a star, and this is a nearby planet. As the planet orbits the star, its mass influences the star's motion. It wobbles. Stars without planets spin evenly. Stars with planets orbiting them wobble.
And so you see the velocity changing, and then you see a line that's been drawn in. This is a theoretical model that fits the data. And
boy, does it fit the data.
If each one of these dots represents one night of data, one observation of the star, and you can see pretty quickly we knew that something was going on, that the star's velocity was changing, so we knew there was a planet there. And the nice thing is that once we get this mathematical model, and imagine that these future lines are missing here, the line continues, and when we come to the observatory, the next points that we get had better fall right on this line, or our model is wrong. If you look here, the wobble is modulated by a second one.
Yeah.
This one has two planets around it. And
How cool is that?
So stars without any planets would just have a constant velocity. All these dots would lie in a straight line. But a star that has a planet has velocity that changes. The star comes toward us, goes away from us in this orbit. And so that's what we're measuring here.
You think there's life out there?
I think it's likely, extremely likely, that there's some sort of life out there. So it's impossible to describe what that life might be like. I guess the scientist in me wants to stay a little reserved and wait until we have more data to understand what that life might be like.
But what about the romantic, passionate person?
Well, the romantic, passionate person believes that there's life out there and other civilizations and other beings. With all of the diversity of life that we have here on this one planet, it's hard for me to imagine that there isn't life on other planets around other stars.
The moment of truth has arrived for NASA's Mars rover. After a 6-month journey, the rover is about to land on the red planet. This is no easy thing. That last little bit is a free fall, with the spacecraft dropping like a Mars rock. There are small retro rockets to slow the descent, then bouncing like a fumbled football. If all goes well, the Mars rover, with all its precision instruments, will bounce down and roll to a stop somewhere in the target landing zone. Of course, a crash landing is always a distinct possibility. The best way to know what's happened 35 million miles away is if the rover fires up its computer and begins sending radio and video signals back to Earth. If the rover doesn't work, millions of dollars of research go right out the Martian window.
What do we see?
NASA successfully landed 2 rovers on opposite sides of Mars in January 2004. The second rover, Opportunity, landed on the Meridiana Planum and rolled into a small crater. Close examination of the light-colored rocks along the lip of the crater revealed that not all of the Martian surface consists of volcanic lava flows. These small, blueberry-sized pebbles found embedded in the rock appear to be composed of hematite, a common type of iron oxide that forms in the presence of liquid water. Along with that, chlorine, bromine, and sulfur were found in the Martian soil in the same proportions that we see in old ocean floors on Earth. We figure they got there when an ancient Martian sea evaporated. These and other discoveries lead scientists to believe that this area was once soaked in liquid water. Perhaps it was once suitable for life. But while finding water is encouraging, no actual living organisms have been found. So the scientific community is now clamoring for more space missions to continue probing the mysteries of Mars. Because until we actually make contact with or observe space aliens, the question of life in outer space remains, well, a question. If we got a signal from another world, everybody would have to stop and think.
Oh, absolutely. No, I think that it'll have a tremendous impact on us, even if we don't understand the message, simply knowing they're there.
Everything we know about medicine, everything we know about agriculture, everything we know about disease and pest control and so on, is all based on studying that one example of life. Imagine if we had 2. We might be a lot smarter.
Finding evidence for life on another world would just be shattering, I think, to a lot of people. We'd have to reevaluate our place in the universe. We'd have to, I think, unite globally and understand that we're one people.
We've covered a lot of ground, but it's just the tip of the iceberg. Check out eyesofnye.org for more cool science.
The